Factor 4x squared plus 32x plus 60. Notice that the greatest common factor of the terms 4x squared, 32x, and 60 is 4. So you can factor the greatest common factor out of each term, giving you 4 times the quantity x squared plus 8x plus 15. X squared plus 8x plus 15 is of the form x squared plus bx plus c, where b is 8 and c is 15. Because b and c are both positive, the factors p and q must both be positive. So find two positive integer factors of 15 whose sum is 8. The positive integer factors of 15 are 1 and 15 and 3 and 5. 1 and 15 have a sum of 16, and 3 and 5 have a sum of 8. Because 3 and 5 have a sum of 8, the values of p and q are 3 and 5. So x squared plus 8x plus 15 factors as the quantity x plus 3 times the quantity x plus 5. And 4x squared plus 32x plus 60 factors as 4 times the quantity x plus 3 times the quantity x plus 5. Factor each polynomial. Part A, 2x squared plus 7x plus 6. Notice that 2x squared plus 7x plus 6 is of the form ax squared plus bx plus c, where a is 2, b is 7, and c is 6. There is no greatest common factor, so you need to consider the possible factors of a and c. Because b and c are both positive, the factors of c must be positive. Use a table to organize the information about the factors of a and c. The positive integer factors of 2 are 1 and 2. The positive integer factors of 6 are 1 and 6, and 2 and 3. Remember, you must consider the order of the factors of 6 because the middle term formed by the possible factorizations are different. The possible factorizations are the quantity x plus 1 times the quantity 2x plus 6, the quantity x plus 6 times the quantity 2x plus 1, the quantity x plus 2 times the quantity 2x plus 3, and the quantity x plus 3 times the quantity 2x plus 2. The only possible factorization that produces a middle term of 7x is the quantity x plus 2 times the quantity 2x plus 3. So 2x squared plus 7x plus 6 factors as the quantity x plus 2 times the quantity 2x plus 3. Part B, 4x squared minus 7x plus 3. Notice that 4x squared minus 7x plus 3 is of the form ax squared plus bx plus c, where a is 4, b is negative 7, and c is 3. There is no greatest common factor, so you need to consider the possible factors of a and c. Because b is negative and c is positive, both factors of c must be negative. Use a table to organize information about the factors of a and c. The positive integer factors of 4 are 1 and 4 and 2 and 2. The negative integer factors of 3 are negative 1 and negative 3. Remember, you must consider the order of the factors of negative 3 because the middle terms formed by the possible factorizations are different. The possible factorizations are the quantity x minus 1 times the quantity 4x minus 3, the quantity x minus 3 times the quantity 4x minus 1, and the quantity 2x minus 1 times the quantity 2x minus 3. The only possible factorization that produces a middle term of -7 is the quantity x minus 1 times the quantity 4x minus 3. So 4x squared minus 7x plus 3 factors as the quantity x minus 1 times the quantity 4x minus 3. Factor 3x squared minus 7x minus 6. Notice that 3x squared minus 7x minus 6 is of the form ax squared plus bx plus c, where a is 3, b is -7, and c is -6. There is no greatest common factor, so you need to consider the possible factors of a and c. Because c is negative, the factors of c must have different signs. Use a table to organize the information about the factors of a and c. The factors of 3 are 1 and 3. The factors of -6 are 1 and -6, 6 and -1, 2 and -3, and 3 and -2. Remember, you must consider the order of the factors of -6 because the middle terms formed by the possible factorizations are different. The possible factorizations are the quantity x plus 1 times the quantity 3x minus 6, the quantity x plus 3 times the quantity 3x minus 1, the quantity x minus 1 times the quantity 3x plus 6, the quantity x minus 6 times the quantity 3x plus 1, the quantity x plus 2 times the quantity 3x minus 3, the quantity x plus 3 times the quantity 3x minus 2, the quantity x minus 2 times the quantity 3x plus 3, and the quantity x minus 3 times the quantity 3x plus 2. The only possible factorization that produces a middle term of -7x is the quantity x minus 3 times the quantity 3x plus 2. So 3x squared minus 7x minus 6 equals the quantity x minus 3 times the quantity 3x plus 2. Factor -9x squared minus 3x plus 2. Begin by factoring -1 from each term of the trinomial. 9x squared plus 3x minus 2 is of the form ax squared plus bx plus c, where a is 9, b is 3, and c is -2. Because c is negative, the factors of c must have different signs. Use a table to organize the information about the factors of a and c. The factors of 9 are 1 and 9 and 3 and 3. The factors of negative 2 are 1 and negative 2 and 2 and negative 1. Remember, you must consider the order of the factors of negative 2 because the middle terms formed by the possible factorizations are different. The possible factorizations are the quantity x plus 1 times the quantity 9x minus 2, the quantity x plus 2 times the quantity 9x minus 1, the quantity x minus 1 times the quantity 9x plus 2, the quantity x minus 2 times the quantity 9x plus 1, the quantity 3x plus 1 times the quantity 3x minus 2, and the quantity 3x plus 2 times the quantity 3x minus 1. The only possible factorization that produces a middle term of 3 is the quantity 3x plus 2 times the quantity 3x minus 1. So 9x squared plus 3x minus 2 factors as the quantity 3x plus 2 times the quantity 3x minus 1, and negative 9x squared minus 3x plus 2 factors as the negative of the quantity 3x plus 2 times the quantity 3x minus 1. The length of a rectangular state park is 2 miles longer than twice the width. The area of the park is 84 square miles. What is the width of the park? Use the formula for the area of a rectangle to write an equation for the area of the park. Let W represent the width, then 2W plus 2 represents the length. Substituting 84 for the area and 2W plus 2 for the length, you get 84 equals the quantity 2W plus 2 times W. Distributing the W through the quantity 2W plus 2, you get 84 equals 2W squared plus 2W. Now you want to rewrite the equation so that 0 is on one side by subtracting 84 from each side, giving you 0 equals 2W squared plus 2W minus 84. Then dividing each side by 2, you get 0 equals W squared plus W minus 42. W squared plus W minus 42 is of the form W squared plus BW plus C, where 1 is B and negative 42 is C. Because C is negative, the factors P and Q must have different signs so that PQ is negative. So find two integer factors of negative 42 whose sum is 1. The integer factors of negative 42 are negative 42 and 1, negative 1 and 42, negative 21 and 2, negative 2 and 21, negative 14 and 3, negative 3 and 14, negative 7 and 6, and negative 6 and 7. Negative 42 and 1 have a sum of negative 41. Negative 1 and 42 have a sum of 41. Negative 21 and 2 have a sum of negative 19. Negative 2 and 21 have a sum of 19. Negative 14 and 3 have a sum of negative 11. Negative 3 and 14 have a sum of 11. Negative 7 and 6 have a sum of negative 1, and negative 6 and 7 have a sum of 1. Because negative 6 and 7 have a sum of 1, the values of P and Q are negative 6 and 7. So w squared plus w minus 42 factors as the quantity w minus 6 times the quantity w plus 7. By the zero product property, you can set each factor equal to 0. So you have w minus 6 equals 0 or w plus 7 equals 0. To solve w minus 6 equals 0 for w, add 6 to each side, leaving you with w equals 6. To solve w plus 7 equals 0 for w, subtract 7 from each side, leaving you with w equals negative 7. A negative width does not make sense, so you should use the positive solution. So the width of the park is 6 miles.